Welcome everyone to chapter 10. Here we're going to look at real numbers. And you may say, well, I'm pretty sure all the numbers I've been dealing with are real, and you would be correct. If you want to deal with numbers that are not real but imaginary, I suggest taking Math 60. But really what this chapter is about is not only doing operations with real numbers that we've done before, but also dealing with negative numbers. And so the first thing we're going to do is just look at how we classify numbers. So there's a few ways we can do it. We have certain sets of numbers we like to talk about. One of them is the natural numbers. And I've been the natural numbers for Halloween. These are the numbers that are used to count things. I think of the first numbers you learn when you're a kid: one, two, three, and so on. Then there are the whole numbers, which are very close to the natural numbers, except they also include the number zero. Integers are an even larger set of numbers that include all of the whole numbers, plus, if you will, the negative whole numbers. So, for example, -1, -2, -3. So they're like whole numbers. They're 1, 2, 3. They're not like 1.5, but they can also be negative. You can think of the numbers that you would use if you were going to label a number line, which was done here. Okay, so like -5, -4, and so on. Note 0 is included here, right? Because it's a whole number. And then all of the positive integers as well: 1, 2, 3, 4, and so on. The rational numbers is an even larger set of numbers. And this is the set of numbers that includes every number that can be written as a fraction. So think of the integers we've just talked about. Think about -2. Can that be written as a fraction? Yeah, it can. -2/1 is a fraction. But if you think of a number like 1/2 or 0.5, that's also a rational number because it can be expressed as a fraction. So it's going to include all of the integers, but it's also going to include fractions and decimals that are repeating or finite. So if you have a decimal like 0.5, right, that's 1/2, that works. If you have a repeating decimal like 0.333333 that goes on forever, remember that's the same thing as 1/3, so that also works. Okay, so if they have a repeating decimal or the decimal ends like 0.5, then you're good. Okay, and so if you look at this diagram, we've kind of gone from the smallest set of numbers up to the biggest. So at the bottom there on the left, you have natural numbers. Okay, so the counting numbers you learned as a kid. And then the whole numbers includes all those natural numbers plus the number 0. When you add in the integers, it includes all the whole numbers, but then also includes the negatives. So -1, -2, and so on. And then the rational numbers are going to include everything in those other three groups, but also a whole bunch of fractions. So any number that can be expressed as a fraction, so that can have a finite decimal, or it can have a repeating decimal. The other category of numbers that we like to talk about are the irrational numbers. Okay, and these are numbers where they do not have a repeating decimal. In other words, they kind of go on forever. If you look at pi, I can punch pi into my calculator and I will get an approximation of pi. So my calculator says it's 3.141592654. But the decimal actually goes on forever and forever and forever. Or like the numbers go on forever and forever. Okay, so another way to think of it is if you tried to place pi on a number line. Okay, let's look at this number line up here. If I tried to put 3.14 and so on, it's somewhere around here, but I can never quite touch its exact position because no matter how close I get, it goes on and on and on in decimal places. It gets more and more and more and more accurate. And so you could write digits down for something like pi forever, and you're never quite going to express the exact number because you could always get a little bit more precise. You can go even further in decimal places. Another example would be something like the square root of 3. Okay, and if you punch that on your calculator, you'll see that it doesn't have a finite decimal. In other words, the decimal place doesn't end. Okay, oh, I'm doing this wrong on my calculator, hang on. Square root, there we go, square root of 3. Okay, so my calculator says 1.7320508088. But that's not actually the square root of 3 because there's even more decimal places that go on beyond. So those are the rational numbers, or sorry, the irrational numbers, the numbers that do not have repeating or finite decimals. Okay, so just a reminder from before that integers are like the numbers you use to name points on the number lines. I like to think of it as the whole numbers and the negative whole numbers, if you will. And so in this list, see if you can circle the integers. And what you should end up circling are these ones here, including 0. Okay, now let's talk a bit about negative numbers. So far in math, we've always talked about positive numbers. Sometimes we also have negative quantities though. For example, if you're dealing with height, you can have the Empire State Building, which is 1,250 feet tall. Okay, so above the ground. So that would be plus 1,250. But sometimes you have things below a reference point. So for example, Death Valley is 282 feet below sea level. So if you have to find sea level at 0 feet, then Death Valley is actually at negative 282 feet. Another time we often encounter negatives is with temperature. So for example, the temperature in Winnipeg might be 10 degrees below 0. Okay, so that would be negative 10. Okay, to represent integers on the number line then, we could write them on this number line. If they're on the left, they're going to be left of the 0 in that red area there. And so that means they're less than 0. If it's positive, it would be on the blue. So if we were going to label these numbers here on our number line, let's go ahead and do that. So we have negative 1. So that's going to be right here. Okay, and that's already labeled there for you, negative 1. And then 6 is right here. 4, 7, and negative 9. Okay, well, putting them on the number line like that would help us with our next objective, which is to order real numbers. So sometimes you might be asked to put them in ascending order. Think about a staircase. If you go up a staircase, you call that ascending. So you're going from the smallest to the largest. The smallest number is the one that's furthest left. Okay, so you're going left to right on the number line. And so here's an example right here of a set of numbers that is written in ascending order. Okay, descending order, think about stairs. You're going down the staircase. So you're going from largest to smallest. And once again, they've got a set of numbers here that is an example of that for you. So we start with the largest number. We go to the smallest, which is kind of like the most negative, the one that would be the furthest left on that number line. So let's do one of our own. So here they've asked you to place the following set of numbers in ascending order. So you're going up the staircase. So pause this video and go ahead and do that. Okay, and hopefully you actually did it. I realized that actually it's already done for you right here. Okay, so we start with the most negative number because that's the smallest, negative 8. And then we would go all the way up to our highest number, which is 9. Okay, another property of numbers you might sometimes want to know is the minimum value or the maximum value. People spend days, years figuring out minimums and maximums for certain things. The minimum is going to be the least element or the lowest number. The maximum is going to be the greatest element or the highest numbers. So here we're asked to determine the min and max of each of these sets. So the minimum is going to be the smallest number, which is kind of like the most negative. So that would be negative 8 here. And your max here then would be 9. So pause this video and try that for the next ones. Okay, let's do these together now. So the minimum of C is negative 13, and the max is 15. And B, we have a minimum of negative 20 and a max of 18. And D, we have a minimum of negative 9 and a max of 8. Okay, and the last part of this section is talking about absolute values. So one way to think about absolute value is it's the distance on a number line between 0 and the number you're interested in. Okay, so in other words, we don't really care if that number's in the negatives or the positives. We're only looking for what its distance is from 0. The way I like to think of it is your absolute value signs, which are like these little sticks here. These are like magic wands, and they make whatever is inside of those magic wands into a positive value. So if you have absolute value of x, then it's just going to be x because that was positive. If you have absolute value of negative x, poof, it made that negative x positive, and now you have x. So a more kind of concrete, specific example down here, if you have absolute value of 5, okay, poof, we made it positive. Well, it already was, so the answer is 5. Absolute value of negative 5, poof, we make it positive, it becomes 5. Okay, and if you wanted to think of that more on the number line, whether we have positive 5 or negative 5, here's 0, negative 5 here, our distance from negative 5 to 0 is 5. From 5 to 0, our distance is also 5. So that's why both of those things equal 5. So here's some practice for you. Let's do a few together first. So if we were to find the absolute value of that first one, 8, well, it's already positive, so the answer is just 8. For B, we're looking for the absolute value of negative 4. So those magic wands made it positive, which made it into a positive 4. Okay, the next one is interesting because you have to consider where the absolute value signs are. Okay, here, whatever is inside this absolute value, poof, is made positive. So that becomes positive 9. And then we have a plus sign. And then whatever was inside this, our magic wands here, our absolute value signs, poof, became positive. Well, it already was, so it's just a 3. And then we get 12. So if you've got kind of two sets of absolute values like that, only whatever is within those magic wands is becoming positive. So pause this video and try the rest. H will be a bit of a challenge, but give it a try. Okay, and let's do this together. Hopefully you had a chance to try it on your own. So D, absolute value of 9 is just 9. And then we've got plus absolute value of 3 is 3. So here we would get 12. For E, we have absolute value of negative 8. Those absolute value signs, poof, make it positive, and we've got positive 8. Okay, next one is also kind of a challenging one. We didn't really do one like this. Okay, we've got absolute value of 9 minus 4. The absolute value signs are on the outside of that operation. So first we have to do 9 minus 4, which gives us absolute value of 5. And then poof, we make it positive. Well, it already was, so we get positive 5 there. Okay, next one, we've got absolute value of 4, which is positive 4. And then we have a minus, and then absolute value of negative 10 becomes positive 10. So now we have 4 minus 10, which gives us negative 6. And we'll talk more about that in the next section. But we had 4 of something, and we're subtracting 10. If we had $4 and then we had to give away $10, well, now we owe 6. So it's negative 6. Like I said, we'll talk more about that in the next section. And then this last one, we've got absolute value of 6 minus 10. So it's absolute value of 6 minus 10 gives us negative 4. And so we end up with positive 4. So once again, whatever's within those magic wands, we're going to change into a positive.